Squaring the Circle. Welcome to the Shakaama Live Show with your host, Shakaama. Squaring the circle is a problem proposed by ancient geometers, namely from Egypt, the Africans located in the northwest. It is the challenge of constructing a square with the same area as a given circle by using only a finite number of steps with compass and straight edge. So for all of you all who are confused about how it's a challenge, that's the problem. You're using only a compass and a straight edge. You're only able to draw lines and circles. It may be taken to task whether specific axioms of Euclidean geometry concerning the existence of lines and circles entail the existence of such a square. However, in 1882, the task was proven to be impossible as a consequence of the Lindenham-Weierstrass theorem, which proves that pi is a transcendental rather than an algebraic irrational number. That is, it is not the root of any polynomial with rational coefficients. It had been known for some decades before then that the construction would be impossible if pi were transcendental, but pi was not proven transcendental until 1882. Approximate squaring to any given non-perfect accuracy, in contrast, is possible in a finite number of steps since there are rational numbers arbitrarily close to pi. The expression squaring the circle is sometimes used as a metaphor for trying to do the impossible. For those of you involved in the conspiracy world, squaring the circle is also used in Masonic circles. And I don't mean to make a pun. The term quadrature of the circle is sometimes used to mean the same thing as squaring the circle, but it may also refer to approximate or numerical methods for finding the area of a circle. Historically, methods to approximate the area of a given circle with a square, which can be thought of as a precursor problem to squaring the circle, were known already by Babylonian mathematicians. The Egyptians' Rhind papyrus of 1800 BC gives the area of a circle as 64 over 81 d squared, where d is the diameter of the circle. In modern terms, this is equivalent to approximately pi by 256 over 81, a number that appears in the older Moscow mathematical papyrus and is used for volume approximates, i.e. Hecate. Indian mathematicians also found an approximate method, though less accurate, documented in the Shulba Sutras. Archimedes proved the formula for the area of a circle, a equals pi r squared, where r is the radius of the circle, and showed that the volume of pi lay between 3 plus 1 over 7, which of course he retrieved such mathematical solutions from the Africans, and of course very few Greeks gave credit to Africans, although they are well known to have traveled to Africa to study math. The first known Greek to be associated with the problem was Anaxagoras, who worked on it while in prison. Hippocrates of Chios squared certain lunes in the hope that it would lead to the solution. See Lune of Hippocrates. Antiphon and Sophist believed that inscribing regular polygons within the circle and doubling the number of sides would eventually fill up the area of the circle, and since a polygon can be squared, it means the circle can be squared. Even then, there were skeptics. Eudemus argued that the magnitude cannot be divided up without limit, so the area of the circle will never be used up. The problem was even mentioned in Aristophanes' plays The Birds. It is believed that Oenopides was the first Greek who required a plain solution, that is, using only a compass and straight edge. James Gregory attempted a proof of its impossibility in Vera Secule et Hyperbolae Quadratura, the true squaring of the circle and the hyperbola, in 1667. Although his proof was faulty, it was the first paper to attempt to solve the problem using the algebraic property of pi. It was not until 1882 that Ferdinand von Lindermann rigorously proved its impossibility. The Victorian age mathematician, logician, and author Charles Ludwig Dodson, better known under the pseudonym of Lewis Carroll, also expressed interest in debunking illogical circle squaring theories. In one of his diary entries of 1855, Dodson listed books he hoped to write, including one called Plain Facts of Circle Squares. In the introduction, A New Theory of Parallels, Dodson recounted an attempt to demonstrate logical errors to a couple of circle squarers, stating, quote, "The first of these two misguided visionaries filled me with great ambition to do a feat I have never heard of as accomplished by man, namely to convince a circle squarer of his error. The value my friend selected for pi was 3.2. The enormous error tempted me with the idea that it could be easily demonstrated to be an error. More than a score of letters were interchanged before I became sadly convinced that I had no chance." A ridiculing of circle square appeared in Augustus de Morgan's A Budget of Paradoxes, published posthumously by his widow in 1872. Having originally published the work as a series of articles in the Athenaeum, he was revising it for publication at the time of his death. Circle squaring was very popular in the 19th century, but hardly anyone indulged in it today, and it is believed that De Morgan's work helped bring this about. Why it is impossible. The solution of the problem of squaring the circle by compass and straight edge demands construction of the number, the square root of pi, and the impossibility of this undertaking follows from the fact that pi is a transcendental, non-algebraic, and therefore non-constructible number. If the problem of the quadrature of the circle is solved using only compass and straight edge, then an algebraic value of pi would be found, which is impossible. Johann Heinrich Lambert conjectured that pi was transcendental in 1768, in the same paper in which he proved its irrationality even before the existence of transcendental numbers was proven. It was not until 1882 that Ferdinand von Lindermann proves its transcendence. The transcendence of pi implies the impossibility of exactly circling the square, as well as of squaring the circle. It is possible to construct a square with an area arbitrarily close to that of a given circle. If a rational number is used as an approximation of pi, then squaring the circle becomes possible, depending on the values chosen. However, this is only approximating and does not meet the constraints of the ancient rules for solving the problem. Several mathematicians have demonstrated workable procedures based on a variety of approximations. Bending the rules by allowing an infinite number of compass and straight edge operations, or by performing the operations in certain non-Euclidean geometries, also makes squaring the circle possible in some sense. For example, although the circle cannot be squared in Euclidean space, it sometimes can be in hyperbolic geometry under suitable interpretations of the terms. As there are no squares in the hyperbolic plane, their role needs to be taken by regular quadrilaterals, meaning quadrilaterals with all sides congruent and all angles congruent, but these angles are strictly smaller than right angles. There exist in the hyperbolic plane, countably, infinitely many pairs of constructible circles and constructible regular quadrilaterals of equal area, which, however, are constructed simultaneously. There is no method for starting with regular quadrilaterals and constructing a circle of equal area, and there is no method for starting with a circle and constructing a regular quadrilateral of equal area, even when the circle has small enough radius such as a regular quadrilateral of equal area existence. Here's the reason for the impossibility. When we draw a circle, we as humans assume that the circle has some sort of volume of width to it, and that's not the case. A circle drawn perfectly would have an infinite number of points along the circle. You understand that? Does that make sense to you? So this infinite number of points along the circle would mean to have a square of equal proportion, equal area, is an impossibility. Well, it was with the math of the day. Now let's look at a modern approximation constructions. Though squaring the circle is an impossible problem using only compass and straight edge, right? That's the rule, right? Approximations to square the circle can be given by constructing a length close to pi. It takes only minimal knowledge of elementary geometry to convert any given rational approximation of pi into a corresponding compass and straight edge construction. But construction made in this way tend to be very long-winded in comparison to the accuracy they achieve. After the exact problem was proven unsolvable, some mathematicians applied their ingenuity to finding elegant approximations to squaring the circle, defined roughly and informally as constructing that are particularly single-minded among unimaginable constructions that give in similar precision. Among the modern approximation construction was one E. W. Hobson in 1913. This was a fairly accurate construction which was based on constructing the approximate value of 3.14164,079, which is accurate to the fourth decimal. It differs from pi by about 4.8 times 10 to the negative fifth root. Indian mathematician Srinivasa Ramanujan in 1913, Carl Oates in 1963, Martin Gardner in 1966, and Benjamin Bold in 1982 all gave geometric constructions for 355 over 113, which equals 3.14159292035, 3823008 counting, which is accurate to 6 decimal places of pi. Srinivasa Ramanujan in 1914 gave a ruler and compass construction, which was equivalent to taking the approximate value of pi to be 9 squared plus 19 squared over 22 to the fourth power, which equals the fourth root of 2,143 over 22, which is equal to 3.1415926525826461252, which is given 8 decimals places of pi. He described his construction to line segment OS as follows. Quote, let AB be a diameter of circle whose center is O. Bisect the arc ACB at C and trisect AO at T. Join BC and cut off from it CM and MN equal to AT. Join AM and AN and cut off from the latter AP equal to AM. Through P draw PQ parallel to MN and meeting AM at Q. Join OQ and through T draw TR parallel to OQ and meeting AQ at R. Draw AS perpendicular to AO and equal to AR and join OS. Then the mean proportion between OS and OB will be very nearly equal to 1/6 of the circumference, the error being less than a 1/12 of an inch when the diameter is 8,000 miles long, which means it is very precise and only marginally erroneous when the circle is very large. In this quadrature, Ramanujan did not construct the side length of the square. It was enough for him to show the segment OS In the following continuation of the construction, the segment OS is used together with the segment OB to represent the mean proportionals. Red segment OE. Continuation of the segment construction up to the search side length of the square. By the way, anybody still listening, I'm reading something that's like 3 feet away, and it's the size of a pin. I have really good eyesight. I can see it clearly, but I mean, it does take some concentration. Extend AB beyond A and beat the circle arc B subscript 1 around O with radius OS. It results S. Bisect the segment BS1 in D and draw the semicircle B subscript 2 over D. Draw a straight line from O through C up to the semicircle B subscript 2. It cuts B subscript 2 in E. The segment OE, which was defined before, is the mean proportional between OS and OB, also called geometric mean. Extend the segment EO beyond O and transfer EO twice more. It results F and A subscript 1, and thus the length of the segment EA1 with the above described approximation value of pi, the half circumference of the circle. Bisect the segment EA subscript 1 in G and draw the semicircle B subscript 3 over G. Transfer the distance OB from A subscript 1 to the segment EA subscript 1. It results H. Create a vertical from H up to the semicircle B subscript 3 on EA subscript 1. It results B, capital B subscript 1. Connect A subscript 1 to B subscript 1. Thus, the searched side A of the square A subscript 1, B subscript 1, C subscript 1, D subscript 1 is constructed, which has nearly the same area as the given circle. For example, to illustrate the errors, in a circle of radius r equals 10,000 kilometers would be the fault of the side length of A, approximately negative 2.8 millimeters. In the case of a circle with a radius of 10 meters, would be the area of the surface A, approximate minus 0.1 millimeters squared. In 1991, Robert Dixon gave construction for 6 over 5 plus lambda, and the square root of 40 over 3 equals 2 times the square root of 3, which equals 3.14153333870509461863. Kochanski's approximation, though these were only accurate to 4 decimal places of pi. Another example of a modern squaring of the circle, 2 times the square root of 25 over 36 plus 1 over 6 plus 348 plus 5 to the square root of 43 over 36 times 72 plus the square root of 143 squared, which results in 1.7724538414193436 squared, which equals 3.14159261996218. 7 decimal places are equal to those of the square root of pi, respectively equal to those of pi. Now, for the Masonic translation of this, it's very open and apparent. It's just simply that you do not know the secrecy of the order. I'm sorry, I'm used to saying order because of the Jesuits. But let's discuss the Masonic square and compass. Freemasonry's square and compass symbol is a mystery to the media, scholars, historians, and even to the most Freemasons. No one knows where it came from or what it means. We'll see how this symbol actually holds an ancient, mystical, and magical meaning that can illuminate initiates. Most Freemasons, when asked the meaning of their square and compass logo, state, both are architects' tools to teach symbolic lessons. However, The square encompasses logo has a meaning that goes much deeper than merely teaching lessons. Notice how the compass tool on top draws a circular shape. The square tool at the bottom draws a square shape. When placed together, as in a logo of the Freemasons, the compass tool and the square tool form a square and circle. The square and circle shapes are related to Euclid's 47 problem of squaring the circle, said to be the primary goal of the Masonic craft. Squaring the circle, however, does not in this case refer to a mathematical problem. It is a spiritual reference to man's instinctive quest to harmonize our physical and spiritual nature. Since antiquity, the square has represented the physical body, the circle, on the other hand, has always represented the soul. The square encompasses thus symbolizes man's state as an eternal soul manifested in a temporary body. The circle is our spiritual side that cannot be seen, heard, touched, tasted, or smelled. It is our true inner and perfect self, the part we feel when we close our eyes and think, me. Quote, in Renaissance poetry generally, the circle is a symbol of perfection and a symbol of the human soul. J. Douglas Canfield, University of Arizona. The compasses, however, are bounded by the square. Our circle is bounded by our body, thus here of a four-sided square and of how we experience nature in fours. The four cardinal points, north, south, east, west, the four seasons, winter, spring, summer, fall, the four elements, earth, air, wind, fire, the four states of matter, solid, liquid, gas, plasma. Four represents the imperfect physical body as well as earthly desires and carnal appetites that weigh the body down. Human life is vulnerable and temporary, in stark contrast with the invulnerability and permanent soul. Quote, there is one sign which has never changed its meaning anywhere in the civilized world, the compass and the square, a sign of the union of the body and the soul. Deming Wagstaff, Wagstaff Standard Masonry, 1922. Quote, the compasses stand for the spiritual side of man, while the square appertains to the material world. The square represents matter. In the case of the compasses, they represent the spiritual. J.S. Ward, interpretation of our Masonic symbols. Quote, a man is a god in ruins. Emerson. We are fallen angels, sparks of the divine, now experiencing the material world, as William Rimmer's wonderfully esoteric portrait, Evening, Fall of Day, illustrates. We have all fallen and descended into matter, which is the material world in which we now live. The two tools, square and compass, symbolizes man's double nature after the fall. Quote, the compass, as a symbol of heaven's, represents the spiritual portion of this double nature of humanity, and the square as a symbol of the earth, as material, sensual, and baser proportions. Albert Pike, Morals and Dogma. Interestingly, many scholars and philosophers have remarked upon this type of symbolism in the square and compasses. Quote, according to this mystic doctrine, all souls have pre-existence and have descended from the spiritual world into the earthly prison of the body. John Yanker, The Arcane Schools, late 1800s. Quote, ancient mythicism considered and named those souls incarnated on earth as the dead. To die was to incarnate. Death was the tomb of the flesh. Alvin Kuhn, mid-1900s. Quote, the human body is the tomb of transformation, the grave into which the soul descends for the purpose of working out its own salvation for transformation and improving self, and descending out of it the stronger and wiser for the experience. W.L. Wilmshurst, early 1900s. The Greek philosophers understood this concept and even went as far as to say the soul is imprisoned in the body because the body must be cared for and must constantly breathe, eat, drink, maintain a constant temperature, fight disease. The body cannot endure forever and will eventually be destroyed by death, at which point the soul is free again. The soul, though trapped in the human body as we are today, is far from powerless, because it is eternal and the soul comes complete with its own inherent powers, powers that can be rediscovered and exercised right here, in the material world. Though in a fallen state, the soul never lost these powers. They have merely been covered up by the body, rendering them unrecognizable. Masonry exists not only to reveal to man the presence of his inner soul, but to help him rediscover his higher powers, powers that have been covered up by the very body he inhabits. So, this video has laid bare the lost secret of Freemasonry. It is that man is both a square body and compass soul. The secret, once a common doctrine in the ancient pagan cultures, had to be hidden away and kept secret from the Holy Inquisition for fear of reprisal. Its wisdom teaches the forbidden doctrine that each of us deep down is a god encased in the matter, a soul inside a body. We can clearly see our body, but the compass teaches us about the part we can't see, the soul. This is the whole idea of initiation to a lost sacred wisdom. The compass and the square symbolize, they are symbols of your soul and your body, your soul inside your body. Now, do you believe that everybody has a soul and that your body is simply covering up the soul and it is released when you release your body? Answer below. And for mathematicians, have you squared the circle? Please like the video for all of the knowledge that I tried to give you all and try to illuminate all of you free of charge. You can donate to the channel at patreon.com/Shakaama. Thank you so much.
There's a distance between us. It's getting hard to reach out. Haven't seen you in seasons, but all I hear is your voice. I know my limits, you can break me.